Hello, yes, and welcome to our objective 3.6 sample problems where we're going to practice graphing exponential functions a little more. So the first thing we're going to do here is we're not going to do any graphs, we're just going to go through the steps. So remember, for these first two problems, we're going to look at, is it growth or decay? What's the horizontal asymptote? What's the domain? What's the range? So for number one here, I see my base is 0.25. Well, 0.25 is less than 1, which means this is decay. My horizontal asymptote, remember, corresponds to my vertical shift. So since I moved down 2, I would say y equals -2 for my horizontal asymptote. My domain is always -infinity to infinity for exponential functions, and my range in this case would be -2 to infinity to correspond with my horizontal asymptote. Now on number 2, my base is 7. So 7 is more than 1, so this is growth. My horizontal asymptote corresponds to my vertical shift, so y equals 14. My domain, of course, is always -infinity to infinity. And my range, in this case, would be 14 to infinity. So there's the first part of things we're looking at when we graph. Next, we're looking at the x and y intercept. So let's do that here. So looking at number 3, let's do this one algebraically. So we'll say for x-intercept, remember we say 0. For y equals 3 to the x minus 4. So I add 4 to both sides, so I get 4 equals 3 to the x, which I can now convert to a logarithm. It'd be log base 3 of 4 equals x. So in my calculator, I will say log of 4 divided by log of 3 for my change of base. Press enter. 1.26 would be my x-intercept. Now for my y-intercept, remember I set x equal to 0. So I'd say y equals 3 to the 0 minus 4. Well, anything to the 0 power is 1, so this would just become 1 minus 4, which means y equals -3. So I would write 0, -3 for my y-intercept. So that's how we can do it algebraically. We can also do it graphically. So for graphically, I'm going to need to start by plugging in my equation here. So I'll say parentheses 2 divided by 3 to the x minus 4 and then plus 1. And I'm going to hit graph. Now notice what happens here. All right, think about what's occurring here, specifically with this, specifically with that. Plus 1. That means I shifted up 1 unit. That means my horizontal asymptote is at y equals 1. That means my graph will never go below 1. What does that mean? That means we will not have an x-intercept. My graph will never go below y equals 1. It'll never go below that point. Therefore, it will never cross the x-axis. So I don't have a y-intercept here. Now, to figure, an x-intercept. I don't have an x-intercept here. Now to figure out my y-intercept, I'll hit second table. When x is 0, y is 6.06. So 0, 6.06. And there we go. So not every exponential function will have an x-intercept, but every exponential function will have a y-intercept. All right. So now that we've gone over those, let's put it all together. Go ahead and get going here. We're going to identify all the information. We're going to draw a table, and then we're going to graph our function. So let's start with this first equation. Now this one's a little tricky. So my base of the exponent is 1/2, right? So this is decay. My vertical shift moves it down 5, so that means my asymptote is y equals -5. My domain is always -infinity to infinity, and my range would be -5 to infinity. So this one will have an x-intercept because we moved it down. Now if we were to move it up, we would not have an x-intercept. We'll see what that looks like here in a sec. So I'm going to type this in. So I'm going to say 3 times 1/2 to the exponent 5x plus 2 and then minus 5. And I'm going to hit graph. Wow, look at how quickly it decays before it flattens out. So I'm not going to get a lot of points on this one. So let's do second calc. Let's find my x-intercept to start. So I'm to the left of it, I'm to the right of it, I press enter, negative 0.55, negative 0.55 comma 0 for my x-intercept. Now to find my y-intercept, second table. I mean, look at this. I mean, it goes from 0 to negative 2. It's already over 700. That's wild. So for this one, for this xy table, let's do negative 1, 0, and then, I mean, we can do 1 and 2, I suppose, because 3 is showing negative 5. We know, of course, it will not actually touch negative 5. It's just the calculator is showing it's so close to negative 5 that it needs to run. Look at negative 2. It's negative 4.999. All right, so moving on, it's just rounding up to negative 5. That's pretty wild. So negative 1 is 19. 0 is negative 4.25. 1 is negative 4.97. And negative 4.99. Okay. So my y-intercept is 0, negative 4.25. So I have all the information I need now. So let's go ahead and graph this. Y equals negative 5. There's that asymptote there. Negative 4.25 would be right here. Negative 0.55 would be right there. And we're not even going to get to 1 here. So we're going to do this and then just shoot it straight over to give us that incredible decay that we have here in this graph. That's wild. Awesome. So that's number 5. Let's look at number 6 here. This time, our base is E. E is approximately 2.718, so that's definitely more than 1, so we'll have growth. My vertical shift moved it up 2, so my asymptote's y equals 2. My domain, negative infinity to infinity. My range would be 2 to infinity. Now, think in mind here. If my asymptote is at 2, and my graph is staying above the asymptote, it's never going to cross the x-axis, is it? So I know this will not have an x-intercept. Let's go ahead and plug it into our graphing calculator to see what we get here. So I'd say parentheses 1/2 times e second e to the x minus 4 and then plus 2. And let's hit graph. Look, see, we're not going to cross that x-axis. And there's our exponential growth. So let's hit second table. So at 0, it's 2.01 would be my y-intercept, wild. Now, what values do I want to have? I'm going to start at 4, it looks like. Yeah, let's go 4. We can go 3 to 6. I think that'd be pretty good. Now, they don't have to be consecutive. I think it's best if they are, because that allows you to really be precise on the growth or decay that occurs. So I'll say 2.18, 4 is 2.5, 5 is 3.36, 6 is 5.69. Now, of course, we also have 0.201. So basically on the asymptote. Remember, it'll never actually touch the asymptote, but it's pretty darn close already. 2.18, 2.5 at 4, 5 is 3.36, 6 is 5.69, and then my next one's off the graph. So I'm going to go ahead and try to create this function here. Beautiful. Add arrows, and there we have it. Lovely. Well done, well done. All right, one more. Hopefully we're feeling pretty confident by now. So let's look at the information we can see. So my base is 3, so I'm dealing with growth. Vertical shift is -1, so that means my asymptote's y equals -1. My domain, of course, negative infinity to infinity. My range in this case would be -1 to infinity. I am going to have an x-intercept on this one, so let's go ahead and graph what we can here. So we'll say 3 to the 2x plus 1, and then -1, and hit graph. See it at that asymptote, and then whoo, shoots up because that base is 3. It's going to go up pretty quick. All right, so let's calculate our x-intercept. So I need to get to the left of it. There we go. I need to get to the right. There we go. Press enter. Negative 0.5. Awesome. Negative 0.5 comma 0. All right, now let's use a table to figure out our y-intercept. Yeah, 1 is at 26. 0, 2. That's pretty good. 0, comma 2. How nice. So x, y. Let's put our table here. I'm going to go, I mean, goodness. We can go negative 2 to 1, I suppose. 2, negative 1, 0, 1. So negative 9.6, or sorry, negative 0.96, negative 0.67, 0 is 2, and 1 is 26. So quite the increase there. So let's go ahead and graph what we know. We have our asymptote at negative 1. Negative 2 is very close to the asymptote. Negative 1 is not quite as close. 0 is 2, and then 1 is literally off the graph. So we can go ahead and do that like so. Voila. And there we have it, graphing some exponential functions, looking at exponential growth, exponential decay, x-intercepts, y-intercepts, domain, range, really covering the gamut of what we need to know for graphing exponential functions. Hopefully we're feeling confident with these. If we are, definitely get started on those practice problems. If you have any questions, as always, reach out to me. This is Mr. Carter signing off. I'll see you next time.